Today we're going to be talking about permutations. It's kind of a weird word, but it's very common in probability. So a permutation goes in our blank. Permutation is an arrangement or listing of objects in which order is important. You'll see this very often when dealing with like people running a race to see who comes in first, second, or third. Maybe picking people from a group, maybe to be on a sports team. So that's what the types of probability problems we're going to be thinking of today, where order matters because only one person can get first, only one person can get second, only one person can get third. Here we can use what we talked about last section with the fundamental counting principle. Remember, that's when we can multiply our outcomes together. When order matters, so in dealing with permutations, it's going to be something where it's like 3 with like a little exclamation mark. This means that we're going to do 3 times 2 times 1. So when dealing with permutations, when order matters, we're going to count down by 1 and multiply. Okay. So those are the kinds of problems we're going to be thinking of. Number 1, you take math, science, language arts, and social studies in school. We want to find the number of possible arrangements of classes. Well, the first time you arrange it, you have 4 options. You can choose math as your first class, science as your first class, language as your first class, social studies as your first class. So 4 is first. So say you choose math first because it's awesome. And then after that, you only have 3 options to choose from. So our next number is 3. So say for the second class you take, you choose language arts. So after you pick your first 2 classes, now you only have 2 classes left to choose from. So 2. Now say for that third class you pick social studies. And then last you only have 1 option. You can only choose science. So 4 times 3 times 2 times 1, that's going to give us 24 ways we can arrange it. So 24 arrangements. And that's our answer. So in math we would look at that as 4 with the exclamation mark. If you see the exclamation mark, that means do 4 times 3 times 2 times 1. So you're just counting down like we said over here. So you just take your number of options here. We had 4, and then you count down. Number 2, in how many ways can the starting 6 players of a volleyball team stand in a row for a picture? So say little Susie is over on the left, that means Susie can't be over on the right. So this is an example where order matters because only one person can be at a place at a certain time. So since there are 6 players, it's 6, and we call this factorial when we have the exclamation mark. So that's 6 times 4 times, or 6 times 5 times 4 times 3 times 2 times 1. And when you multiply that all together, you're going to get 720 arrangements. You don't have to use the word arrangements. You could use outcomes like we did with the last section. On the next page, got a few more examples. Number 3, a team of bowlers has 5 members and they bowl 1 at a time. So since they bowl 1 at a time, this is how we know that it's going to be a permutation. And how many orders can they bowl? So we write 5 factorial, that's equal to 5 times 4 times 3 times 2 times 1. And we're going to get 120. You could also put 100, or I said 120, 180 ways. Number 4, this should be 2, my bad. 2 different letters are randomly selected from the letters in the word math. What is the probability that the first letter selected is M and the second letter is H? So this one is a little bit different because we're only going to choose 2 letters. When we first start out, we have 4 choices. And then the next time we have 3 choices. But that covers our first letter. So our first letter had 4 choices. And then there were, There are 3 choices for letter 2. So it's just 4 times 3. You don't have to do the times 2 times 1 part. So 4 times 3 would be 12. Now, when you are just choosing a certain number, you're only going to multiply that many numbers. So since we had 2 different letters to choose, we only did 2 numbers multiplied together. So we have 12 outcomes. So our probability, we're just going to take that number and put it under 1. So the probability is 1 over 12. Number 5 is going to be very similar. Alex, Aiden, Dexter, and Dion, so we have 4 kids, are playing a video game. If they each have an equally likely chance of getting the highest score, what is the probability that Dion will get the highest score and Alex would get the second highest? So again, we're only caring about 2 people, really, Dion and Alex. We want Dion to get highest, Alex to get the second highest. But we start off with 4 choices, so 4 people can get first place, and 3 people can get second place, so that gives us 12 outcomes. So again, our probability is going to be 1 over 12. And that's it. So if you're being asked for the probability of a permutation like this, just put it under 1 and you're good to go. And that's it.